We're given moles and we're asked to determine how many atoms there are, so we're going to use the conversion factor where 1 mole is equal to 6.022 times 10 to the 23rd of whatever it is that you're counting. In this case, propane molecules. All right, let's start with what's given, which is 2.12 moles. I'll just leave out the substance right now because we're only dealing with one substance here, which is propane. And we're going to use a conversion factor which cancels out the moles. That's the undesired unit, and gives us the desired unit of atoms. Now hold on, we're gonna need another step here. So we need to go from moles to molecules. Moles to representative particles first, and then we can turn molecules into atoms. Because we don't have moles to atoms, this molecule of propane has 11 atoms in it. So let's plug these conversion factors in. Conversion factors, if you recall, are just a set of equalities. So 1 mole is equal to 6.022 times 10 to the 23rd of whatever it is that you're counting. In this case, is molecules. And then we had this second conversion factor to get rid of molecules and end up with atoms, because the question is asking about atoms. So 1 molecule of propane has 3 carbon atoms and 8 hydrogen atoms, so a total of 11 atoms. Now we can punch these numbers in our calculator. All right, 2.12 times 6.022 times 10 to the 23rd times 11, and our answer should have 3 significant figures because that's the original value was given to us in 3, so our answer is 1.40 times 10 to the 25. Atoms are in 2.12 moles of propane.